From this video on, we're going to talk about a series of LeetCode questions about randomization. The first one to be covered today is called Insert, Delete, GetRandom, O1. In this given task, you need to implement a data structure that supports all three operations: insertion, removal, and uniform sampling in O1 time. There are three constraints guaranteed. The absolute value is within the integer range, or the range of 2 to the power of 32. There will be at most 2 times 10 to the 5th operations, and there will be at least one element available for uniform sampling operation. Now let's brainstorm about the solutions together. First of all, I would like to break down the operations we need to support. We need to support insertion, removal, and random sampling in O1 time. What kind of data structure we can use to support insertion in O1 time? In fact, lots of data structure we can use. We can either use list, then we can just append thing at the end of it, or we can use a hash set. Either of them can achieve insertion in O1 time, so we are good here. How about a removal? If we use a list, then if we want to remove something in the middle, then everything afterwards needs to move one step forward, then this will take O1 time in the worst case. So this is bad. How about using a set? The removal in the hash set only take O1 time, so this could be a candidate. How about the random sampling? If we have a list, of course we can do a sampling in O1 time. We can just randomize the value from index 0 to the length of the array minus 1. So this random sampling can be O1, which is good. How about a set? If you know the implementation of the hash set, you'll know that this is not achievable in O1 time. Every time if you want to do a sampling, you need to first convert this set. Basically, it's an array of many hash buckets behind the scene. You need to convert this to a list and then do a sampling. But the conversion here will take O(n) time. So this is an O(n) operation. This is not good. So we're kind of stuck here because there's no single data structure we can use directly to achieve the goal. Now let's dive deeper into the reason why this list is bad. Assuming that we have a list of values here, and let's say now I want to remove a value A. How do I know where this value A locates? I basically need to have a mapping function so that I will know mapping from A to the index here. So this is where A locates. If I just want to naively remove this value from this array, as I said, once I kill it, I need to move all the values afterwards one step forward, and this will take O(n) time. Can we make it faster? In fact, if we just want to remove this value, we don't care about the order of the other values. Let's say this is the value A here, and the end of the array has a value B. Why can't we just do a swapping here? This will result in B, A. Then we can kill this value directly. This will be an O(1) operation. The next question you might ask is, if I do the swapping here, then the mapping function will be broken because now mapping B should not be pointing to the end of the array. It should be changed to this position. This is actually fixable. In fact, once we remove this value here, we'll just additionally fix the mapping. And once we do this, we can make sure the removal actually takes O(1) time. This becomes O(1) operation. And since list can already do insertion in O(1) time, now I can do removal in O(1) time. You can do random sampling in O(1) time. This is the solution we're going to use in the implementation. Now let's jump into the coding part. I would like to start with introducing some variables. First of all, we need to have a container or an array, which is a list of integer and it's default to an empty list. This is the array or container for us to keep all the values. We also need to have a mapping. I will call it index by value. It's a dictionary between integers. It's default to an empty dictionary. This is a mapping for us to look up the index by the given value. For insertion, we'll first check if this value is already inside this index by value mapping. If it's already there, then we'll skip the insertion and return false directly. Otherwise, we will need to first set the index by value for this value to the length of the self-container. The reason we do it first here is because the index needs to be 0 indexed. This will help us get the right index. Afterwards, we will actually append that value to the container. And remember that we need to return true here. The removal is the tricky part. We'll start with doing the check again. This time, its value is not in the self.index by value, going to return false because there's no way for us to remove it. Otherwise, we actually need to do a swapping of the values in the container and also update the index by value mapping. I'll start with dealing with the last value. The last value is the value at the end of the container. I'll first update the mapping. Self.index by value, this last value will be overwritten by self.index by value. After that, I also need to update the container. Self.container, self.index by value, last value. This will be overwritten by container -1. So after these two lines, I'll finish updating for the last value. Now to go ahead and deal with the value itself. I'll first delete the self.index by value mapping for this value. I also need to pop the last element on this container because we already finished the swap. After that, we'll need to return true. The last function that we need to implement is GetRandom, and this is very straightforward now. We need to return self.container. Here we need to random rand int between 0 and length of self.container. Now let's try it out. Cool. It passed the test cases, and let's do the submission. All right. It's not very fast, but it still beats around 60% of the users. That's the end of this video, and thank you for watching.